Factoring review video 3, factoring trinomials, leading coefficient equals 1. Let's define a few terms. By trinomial, I mean an expression, a polynomial of 3 terms. 1, 2, 3, 1, 2, 3, 1, 2, 3. Coefficient, as I said in the previous video, is the numerical part of a multiplication problem. Visually, it's the number in front of a letter. The phrase leading coefficient specifically means the coefficient in front of the variable with the highest power. The highest power here is 2, and the implied coefficient is 1. So when I say leading coefficient is 1, I mean a 1 in front of the first term. Now, there's a variety of ways to approach these. I'm just going to show you one since it's a review. But essentially what you're doing is reversing the FOIL process. As a FOIL problem, there's evidence of the original pieces in this trinomial. For example, the first part of the product is here. Well, since the first part of the FOIL process gave us x squared, then it's probably going to be x times x. The last part of the FOIL process ends up at the last part of the trinomial, the constant term, if you will. So whatever these two numbers are, I know that they have to multiply to get 24. But the problem is there's a lot of ways to multiply to get 24. There's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So which one is the correct pair? Well, that's where the rest of the FOIL process comes into play. The outside and the inside parts of FOIL most of the time are like terms, and as a consequence, they get combined to make the middle term. So we have all sorts of evidence as to what was in the original FOIL problem. Again, because the leading coefficient is 1 and the leading term is x squared, we can take for granted the fact that the first term in each factor was just an x. But as far as the second terms in each factors, the constants, if you will, I know 2 things about them. Their sum is 11, and their product is 24. And now that I know those 2 facts, I can find them. Because remember, when it came to 24, there were only 4 ways to get it. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So which pair is it? The one with the correct sum. 3 times 8 is 24, 3 plus 8 is 11. And more specifically, positive 3 times positive 8 is positive 24. And positive 3 plus positive 8 is positive 11. Which means the 2 numbers in no particular order are positive 3 and positive 8. If you know where to look for the sum and the product, the sum is the coefficient in the middle, the product is the constant term at the end, then you can usually factor these fairly quickly if you can find the correct pair of numbers. Now, the thing that usually makes this a little trickier is the presence of negative signs. I'm going to raise this middle problem up a little bit. Negative 11 and 18. Just to leave some space under it. There we go. Alright, so if the leading coefficient is 1, meaning that the number in front of the x squared is 1, this is a game of what has a sum of the middle term, so sum equals negative 11, and what has a product of the constant term, what has a sum of the middle coefficient, negative 11, the middle term is negative 11x, but I'm focusing on the negative 11, and also has a product of the constant term, which is positive 18. Well, let's go through the factors of 18, or rather I should say the factor pairs. 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. So we only have 3 factor pairs to process. Which of those pairs has the sum of the negative 11? It's a trick question. None of them have a sum of negative 11. If you were thinking 2 and 9, last time I checked, 2 plus 9 is positive 11. I need a sum of negative 11. So what do? And the answer is we have to adjust the signs. Well, think of it this way. If I multiply 2 numbers and they come out positive, the only thing I know is that they were both positive or they were both negative. So it's either all positives or all negatives. But the sum has to be negative, which means I'm looking for a pair of negative numbers. and the correct pair is -2 and -9. They do have the correct sum of -11. They do have the correct product of +18, which means my two factors were, in no particular order, x minus 2 and x minus 9. Again, if you can look at this and think it out and write the answer, that's great. That's actually the skill level I'd like for all of you to be at, but it doesn't hurt to slow down and break it down a little bit if necessary. Let's take a look at the last one, factor x squared plus 4x minus 32. Again, it's the fact that the leading coefficient is 1 that says, try this. Find two numbers whose sum is +4 and two numbers whose product is -32. Again, negatives are going to be an issue here. We'll worry about the negative in a moment. Let's start by writing down every way to get 32. When you're writing down these factor pairs, I would always start with 1 and the number itself, and then slowly bump up the smaller number. 2 goes into 32 16 times, 3 won't go into 32, 4 goes into 32 18 times, 5 won't go into 32, nor will 6 or 7. 8 goes into 32 4 times, but I've already got 8 and 4. When you start repeating, you can stop. But none of those actually multiply to give -32. They all multiply to give +32. In order to make the product negative, I need to make one of the two factors negative. So for example, I could put a negative on the 1 or a negative on the 32, but not both. So how do I know which one to put it on? Well, think about the sum. I need to add two numbers and the answer needs to be positive. When you add two numbers and the answer comes out positive, the bigger number must have been positive. Because if they were both positive, then the bigger one was positive. But if they were opposite signs and the sum came out positive, then the larger of the two had to be positive. So whatever the sum's sign is tells you the sign of the larger number. Since the sum's sign was positive, that means in the products, the larger factor had to be positive. Because the product was negative, that means they had to have opposite signs. I could have used the same analysis up here. Because the sum was negative, the larger factor had to be negative. Because the product was positive, the factors had to have the same signs. And by the way, if you haven't found them yet, it's this bottom pair. When I add -4 and +8, I get +4. But when I multiply -4 and +8, I get -32. They are the correct pair of numbers. And therefore, x minus 4 and x plus 8, or x plus 8 and x minus 4. It's a multiplication problem. It's commutative. Either one of those is correct. Before I wrap up this video, I want to warn you that not all trinomials are factorable. I set up all of these to factor, but there are some that won't. For example, let's say I gave you x squared, we'll keep everything positive, plus, I'll put something at the end, plus 24, let's put 26x in the middle. And you wanted to find the numbers that had the sum of 26 and a product of 24. More specifically, a sum of +26 and a product of +24. If you ran through all of your products for 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which of those has a sum of 26? Answer, none of them. If none of the factor pairs have the correct sum, then it is a trick question to try to factor that trinomial, and the correct answer is it's prime, which means it won't factor. Kind of like prime numbers can't be factored. In the next video, we'll talk about a technique for how to factor a trinomial when the leading coefficient is 1. And the main reason it's an issue is if this isn't a 1, then at least one of these numbers isn't a 1. And so when you form the outer and inner products, these numbers change. So how do we overcome that? I'll show you a technique in the next video, although I know at least 4 or 5 different approaches.